Hey Bioteam. So you've learned that we can use the Hardy-Weinberg equations to predict the alleles and phenotypes in a population's gene pool. Specifically, the gene pool is made up of dominant alleles and recessive alleles, and those frequencies added together will give you 100% of the gene pool. And the population itself, the population of individuals, is made up of homozygous dominant individuals, heterozygous individuals, and homozygous recessive individuals. And if you add up the frequencies of those types of individuals, you would also get 100% of the entire population. So it turns out that populations are only predictable when conditions are stable. That is, when the population is in a state of equilibrium. And in order for a population to be in a state of equilibrium, a couple of factors have to be true. First, the population would have to be large in order to be genetically predictable, because large populations are less affected by randomness, by genetic drift. Second, the population would not have to be undergoing any new mutations, because new mutations would be introducing new alleles into the gene pool and new phenotypes into the population. Next, populations can be predictable if there's no natural selection that's occurring. That is, dominant phenotypes are just as likely to reproduce as recessive phenotypes. Next, populations are predictable only if there's random mating occurring between individuals in the population. That is, the idea that individuals in the population aren't choosing who they mate based on their phenotype. This one's a little bit confusing. So for an example of non-random mating, you could imagine a situation in humans where brown-eyed people would choose only to mate with other people with brown eyes, and blue-eyed people would only mate with blue-eyed people. And as a result, there would be a lot fewer heterozygous children being born than the Hardy-Weinberg equilibrium equations would otherwise predict. That is, there'd be a lot less hybrid offspring being made. All right, and then last, in order to be able to predict a population's genes with these equations, there'd have to be no migration going into or out of the population. That is, no new phenotypes or genes are being suddenly added or lost to the population. So if one or more of these factors is not being met, which is almost always the case, then a population is said to be evolving. That is, the population's gene frequencies are not being stable over time, they're changing. So that's it. At this point, you guys have some practice problems. We'll see you next class.